let's talk about curvilinear motion now. Okay, we have studied rectilinear motion earlier, which was the motion along a straight line. Okay, now we are going to study a motion which is along a curve. Okay, so my particle is moving along this curve. So we know my displacement is what? My displacement is a straight line distance from a reference point. Okay, so for me to define a displacement of my particle, I need a reference point. Let us assume this is my reference point. Okay, O is my reference point. Then this particular distance, straight line distance, defines the displacement of the particle at a time t. Okay, if at time t my particle is at this distance from O, then this distance is my displacement. It is also known as position vector of this particular point. Okay, I'm just going to write in over here that r vector, we know displacement, velocity and acceleration, they all are vectors just like our force. Okay, so your r, which is displacement, is also known as position vector because it defines the position of your particle. Okay, so this is my position vector. Let us suppose I know the position vectors of this particle at different times. Okay, so at time t it is over here. Let us say at time t plus delta t it is at this position. Okay, so corresponding to this position I am also going to have a position vector. Okay, let us say it is this one. Okay, this is my position vector of this particular point, or the position of particle at t plus delta t instant. Okay, let me call this as r dash. Let me call this as r vector. Therefore, what is this distance? This would be, let us suppose this is x. Okay, so what you have is r dash plus x vector is equal to r dash vector. Okay, my triangle law of vectors. Okay, so my x vector is basically what? My x vector is basically r dash vector minus r vector. Okay, this is r dash, which is basically my change in displacement. Okay, this is displacement at instant t plus delta t. This is displacement at instant t. Therefore, this is change in displacement, right? Therefore, my x is delta r vector. Okay, which is equal to r dash vector minus r dash. Okay, so this is, I'm now going to say that this is delta r. Okay, and my average velocity now is, average velocity as we had seen earlier, it is the change in displacement with respect to change in time. Okay, so my average velocity in the instant delta t is going to be change in displacement, which is delta r vector upon time, right? So this is my average velocity, and therefore my instantaneous velocity would be given by the limiting conditions when delta t tends to 0. Okay, so delta t tends to 0, delta r upon delta t, which is dr upon dt. Okay, so this is my expression for instantaneous velocity of a particle which is moving along a curve. Okay, as we said that my velocity is a vector, therefore it must also have a direction, right? Just look at this curve. What is this curve? This is a curve of r with respect to t, right? We are plotting various are position vectors with respect to time. Okay, therefore your dr by dt is going to be tangential to this curve, hence your velocity vector is tangential to the curve which is like this. So this is your velocity vector at time t. Okay, now let's talk about my speed. Okay, look, this particle has traveled from this point to this point along this path. Okay, therefore it has traveled a distance which is equal to this arc, right? Let us call this distance as delta s, where what is delta s? Let me just say that this point is A, this point is B, then my delta s is the length of arc AB. Okay, so this is my delta s. Therefore, my average speed in the interval delta t is equal to delta s upon delta t, and now under the limiting condition when delta t tends to 0, my instantaneous speed is given by ds by dt. Okay, so this is the expression for my instantaneous speed. Understand one thing over here, your modulus of your velocity or the magnitude of your velocity is equal to the instantaneous speed, which is ds by dt, sometimes also referred to as small v. Okay, now let's suppose that at time is equal to t, my velocity is v vector like this. Okay, and at time t plus delta t, my velocity is v plus delta v vector. Okay, which is in this direction, tangential to this point. Okay, so now I can define my average acceleration, which is going to be what? My average acceleration in the interval delta t is equal to delta v vector upon delta t, and hence my instantaneous acceleration is going to be what? It is going to be under the limiting condition when my delta t tends to 0, which basically is equal to dv vector by dt. Okay, therefore my acceleration vector is given by this expression. Since it's a vector, it must have a direction. Let us understand what is the direction of my acceleration vector. Let us suppose that I am plotting the velocities of my motion of the particle of this motion. Okay, so this guy is moving like this. Okay, so at this point it's gonna have a velocity like this. Say at this point it's gonna have a velocity like this. So I am plotting the velocities at different interval of time. Okay, so what I'm going to get is a graph like this. Okay, wherein I have, let's make it a bit nicer, wherein I have my velocities at different interval of time. So let us say at time t I have a velocity of v. Okay, similarly at time t plus delta t I have a velocity of v plus delta v. Okay, something like this. Similarly, let us suppose at time t3 I am going to have a velocity which is represented by this vector. Okay, this particular graph is called as a hodograph of a motion. And what is my acceleration? My acceleration is dv vector by dt. Okay, so if I plot my v graph, dv by dt would be tangential to that curve, hence my acceleration is at this instant it is going to be tangential to this curve, and this is my acceleration vector. Just understand one thing over here, your acceleration is not tangential to the motion curve. it is tangential to the velocity curve. Okay, therefore you would not say that this is the direction of your acceleration. It would be at a direction which is other than tangent to this velocity. Okay, it might be this, but it does not necessarily have to be this. Okay, you would get the direction by plotting your velocity curve. Okay, now let's understand the rectangular components of my velocity and acceleration. Okay, just like we had seen that we could always resolve my force into two rectangular components, fx and fy, we are going to now have rectangular components of our velocity and acceleration. Okay, look, your r vector can be basically thought of as, you could have this distance as, let's say, x, okay, and you could have this distance as, let's say, y. Therefore, what is your r vector? Your r vector is essentially xi plus yj, right? And we know that my velocity vector is dr by dt. Therefore, what I get is dx by dt I plus dy by dt j. Okay, so now I can write my velocity vector as a component in x direction plus a component in y direction. Therefore, my component in x direction is equal to dx by dt, and my component in y direction is equal to dy by dt. Okay, so this is your rectangular components of your velocity. Similarly, we know that acceleration again is what? Acceleration is dv by dt, okay, which is equal to this. If I just copy this expression over here and I paste it over here, so I have copied the expression for v. So this is d by dt of this whole thing. Therefore, my acceleration is what? My acceleration is d square x by dt square I plus d square y by dt square j. Okay, therefore if I resolve my acceleration as axi plus ayj, where ax is the component in x direction and ay is the component in j direction, then my component in x direction is going to be equal to d square x by dt square, and my component in y direction is going to be equal to d square y by dt square. Okay, so if you know x as, let's say, a function of t, and you know y, let's say, as another function of t, then you can always calculate your velocity at different times. Okay, which is going to be what? Which is going to be f1 dash t, okay, I plus f2 dash t. Okay, so this is your velocity vector, and your acceleration would be f1 double dash t I plus f2 double dash t, where what is f2 dash t? f2 dash t is df by dt. Okay, and similarly, what is f2 double dash t? It is d square by f2 expression by dt square. Okay, so this was about rectangular components of our acceleration and velocity. Okay, so if you know the expression of your x or y in terms of t, you can always calculate your acceleration and velocities. Okay, now let's apply the concept of rectangular components to my study of projectiles. Okay, let us suppose that I throw a stone, okay, at an angle alpha with horizontal with some particular speed I call as u. Okay, my stone is going to traverse a trajectory which is going to be like this. Okay, I want to find out what is the range of this trajectory. Okay, what is this range? Okay, what is the maximum height that is achieved? Okay, and I want to find out what is the time that it took to reach from this point to this point. Okay, so we can think that at t is equal to 0, I know the velocity which is u in a direction alpha. Okay, in a direction which is specified by this angle alpha. Okay, so I'm just going to write in for you over here that at t is equal to 0, my velocity is like this. Okay, where this angle is alpha. We know that we can always resolve our velocity vector into horizontal and vertical components. Therefore, I have this as u sine alpha and I have this as u cos alpha. Okay, so what is my velocity Vx at t is equal to 0? My velocity Vx at t is equal to 0 is u cos alpha, and my velocity Vy is equal to u sine alpha. Okay, what else do I know over here? I know that my velocity is always tangent, or my velocity direction is always tangentially to the path of the motion, right? So it's going to be like this, it's going to be like this, it's going to be like this, right? If you consider the highest point, which is this point, at this point my tangent is going to be like this, which is completely horizontal. Okay, so there is no vertical component. Okay, so what else we know over here is at highest point my velocity Vy is equal to 0 and my V is equal to Vx. Okay, another thing that I know in this particular scenario is that this whole motion is under gravity. Okay, therefore the only acceleration that I have is acceleration due to gravity. Okay, so my acceleration is equal to constant, which is equal to g. Okay, my acceleration is constant and is equal to g. I can also have rectangular components of my acceleration, and I realize that ax is equal to 0 and ay is equal to minus g. Okay, as you can see, you have an acceleration in downward directions due to gravity, and you do not have any other acceleration in the horizontal direction. Okay, your total acceleration or your magnitude of acceleration is g, which is completely due to the acceleration in the negative direction. Okay, so I have another two known things in this particular motion. Okay, I know the initial velocity or velocity at t is equal to 0. I know that at this point my vertical component of velocity is 0. I know that acceleration is g and there is no acceleration in horizontal direction. Okay, so as we talked about earlier, when acceleration is 0, we are basically looking at uniform motion, right? Therefore, in x direction, my motion is uniform. Okay, in x direction motion is uniform because in that direction there is no acceleration. Therefore, I can use my equation S is equal to u into t, which is the displacement is equal to initial velocity into time. Okay. Also, I know that when a is constant, I call this as uniformly accelerated motion. Okay. So, under uniformly accelerated motion, as we have derived earlier, I have couple of equations with me, which are v square is equal to u square plus 2as, s is equal to ut plus half at square, and v is equal to u plus at. Therefore, in the horizontal direction, I can use these equations. Okay, sorry, it's the other way around. In the horizontal direction, I can use these equations because in the horizontal direction my acceleration is 0, and in the vertical direction I can use these three equations because in the vertical direction my acceleration is equal to g, okay, which is constant. Now let's find out the time it takes for my particle or a stone to reach over here. Okay, over here, what is the displacement? Look, when we talk about displacement, we need a reference point. So let us assume that this is my reference point. I want to understand what is the displacement of the stone at this point with respect to y-axis. Okay, so my displacement is this much, which is equal to my max height. Okay, so another thing that I know over here is my Vy, which is this, is equal to 0. Okay, so what I'm going to do is I'm going to use this particular equation, okay, where v is the final velocity, u is the initial velocity, a is the constant acceleration. Okay, I know that in y direction, okay, at point of maximum height, my Vy is 0. Okay, in y direction at point of maximum height, Vy is equal to 0. So my final velocity is equal to 0. Okay, if I am trying to understand just this part of the path, then this is the initial thing, this is the final thing, right? So at this point, my final velocity in this direction is 0. In this direction, my initial velocity was u sine alpha. Okay, so if I use this equation, what I get is 0 is equal to u sine alpha. My acceleration is minus g. Okay, this is my reference point. Okay, this is my reference point O. I am measuring distance this way as positive. Okay, so this is positive direction. My acceleration due to gravity is acting downwards. Therefore, acceleration is negative. Okay, so I have u sine alpha. A is minus, so minus g into t. Okay, so what is my t? My t is equal to u sine alpha by g. Whoops. Another thing to note over here is your path, which is this, is totally symmetric with this path. Okay, over this particular trajectory, this is going to be your axis of symmetry. Okay, so the time it takes for my stone to reach this point from here is same as the time it takes for the stone to reach over here from here. Okay, So the time for the stone to reach at this place is going to be 2t, where t is the time it takes to reach at this point. Okay, just understand what is happening. Up until this point, my stone is accelerating in the y direction. Okay, this is not acceleration, actually it is deceleration. Okay, over here my velocity is like this, which is initial velocity, and my acceleration is like this. Okay, so its velocity is decreasing up till an instant where it becomes 0, which is over here. From here to here, what is happening is my velocity is increasing. Okay, although it is increasing in this direction. At this point it is absolutely 0, and due to gravity it starts increasing up till it touches the ground. Okay, so these two paths are exactly symmetric. Okay, therefore my total time of flight is equal to 2 into t. Okay, which is equal to 2 into u sine alpha by g. Okay, another equation that I want to use is this particular equation. Okay, just consider this motion up until this point. I have final velocity, okay, which is 0. I am considering only motion in y direction. Okay, only in y direction I can use these equations, because only in y direction my acceleration is constant. Okay, and it is undergoing a uniformly accelerated motion. So my final velocity is 0, my initial velocity is u sine alpha. Okay, what is s? Your s is displacement. Your displacement in y direction is the maximum height. Okay, therefore I can get my maximum height over here if I use this particular equation. V is known to me, u is known to me, a is minus g. Okay, so let us use that. V square is equal to u square plus 2as. V is 0, u is u square sine square alpha. Okay, u is equal to u sine alpha. Okay, therefore u square is equal to u square sine square alpha, and I have acceleration as minus g, so I get minus 2g h max. Okay, which is my displacement in y direction. Therefore what do I get as h max? My h max is equal to u square sine square alpha upon 2g. Therefore I have got my maximum height that the stone achieves. Okay, this height I have got. Okay, we have calculated the maximum height, we have calculated the time it takes to reach from here to here. What's left is we need to find out the range, which is the maximum horizontal distance. Okay, we are talking about horizontal distance or motion around x-axis. Now my motion in x-axis is governed by this particular equation, because there is no acceleration in x-axis direction, there is a uniform motion happening, so I have only this equation that I can use. S is the displacement, u is the initial velocity, which is also equal to the final velocity, because when you have no acceleration, it means that your velocity is constant. Look, a is equal to dv by dt, right? If your dv by dt, or if your a is 0, it means that dv by dt is 0, which basically means that your v is constant. Okay, so in x direction, your speed or your velocity rather is always u cos alpha. Okay, this is one thing that you should know. other thing that we wanted to understand over here is we can use this equation. This is my maximum displacement, okay, which is the range, okay. If I'm talking about this whole motion, then this is the displacement in x direction when I am over here. Therefore, my range is s. I know my initial velocity, therefore I can get my range because I also know my total time taken, okay, which is over here, okay. Therefore, I can say that range is equal to S is equal to U into T, which is equal to U cos alpha into T, which is the time of flight, okay. It took you T seconds to reach from here to here, okay, which is your time of flight, and that time is equal to, where is that? That time is equal to 2u sine alpha upon g. Okay, so I am going to have dot 2u sine alpha upon g. So I get my range as 2u square sine alpha cos alpha by g. Okay, I can also write it as my 2 sine alpha cos alpha is equal to what? It is equal to sine 2 alpha. Therefore, I can write it as u square by g. Okay, this is g. Okay, it is not 2g. We had a g over here, right? We didn't had a 2g over here. So u square by g into sine 2 alpha. Okay. So my range is equal to this. What if you wanted to maximize your range? What would be your range max? My maximum range would be when I would maximize this expression, okay? Your initial velocity is constant, your g is a constant. I could maximize it by altering my angle, okay? And what is the maximum value of this expression? The maximum value of this expression is going to be 1 when this angle is 90 degrees, okay? Therefore, when you throw something at an angle of 45 degrees, you get a maximum range corresponding to that speed of throw, okay? So your Rmax is when you have alpha equal to 45 degrees and that maximum range is equal to u square by g, okay, corresponding to a certain speed, okay. We are not talking about velocity. Velocity is defined by direction also. We are just talking about a certain speed with which you want to throw, and that angle is going to be 45 degrees. So together these two become velocity, okay. Now let's suppose someone tells you to find the velocity at this position, okay. Let us say this is t, okay, this is t. Someone tells you to find the velocity at time is equal to t, okay. What you would do is, look, your velocity in the horizontal direction is constant because there is no acceleration in that direction. Therefore, at any given instant, your ux is going to be u cos alpha. You have to find out what is your vy, okay. Your vx is going to be u cos alpha. You want to find out what is vy, and how you can do that? You can do that by vy is equal to, look, we are using v is equal to u plus at, okay. So what we have is vy is equal to u, which is what? Which is u sine alpha minus gt. Therefore, at any given time, your velocity in y direction is given by this, and your velocity in x direction is constant. Therefore you can calculate your velocity, which is going to be what? Vx square plus Vy square, and you can calculate this angle, which is going to be your tan theta is going to be Vy upon Vx. Okay, let's look at an example. We have a projectile which is starting from rest. Okay, starting from rest means its initial velocity is 0 and the projectile is thrown in the air. Okay, so if this is my ground, it is thrown something like this. Okay, at any time t, the acceleration of the projectile is given by this expression. Okay, 2I plus 12 t square j. So your acceleration in x direction is 2 and your acceleration in y direction is 12 t square. Okay, at any given time t. We have to find the radius of curvature of the path followed by the projectile at t is equal to 5 seconds. Okay, so if this is the path followed by my projectile, my radius of curvature is given by rho, where rho is my radius of curvature, is equal to 1 plus dy by dx square the whole raised to power 3 by 2 upon d square y by dx square. Okay, where this curve is y, which is a function of x. Okay, this is the equation of this curve. Okay, and if you know the equation of this curve, then the radius of curvature at any given point can be calculated by this formula. Okay, so we need to calculate radius of curvature. Therefore we must find out what is the equation of the path followed by my projectile. We need to find the equation of this curve. Okay, let's look at the acceleration of this projectile again. We have the acceleration in x direction as constant. Okay, so in x direction my projectile goes through a uniformly accelerated motion. Hence I can use s is equal to ut plus half at square to find out the displacement in x direction. Okay, and in y direction my acceleration is 12 t square, which is variable. Okay, whenever we have variable accelerations, we use a is equal to either dv by dt or d square x by dt square or v dv by dx. Okay, depending upon what we need to know. Okay, so at any given point in time, my projectile is at sx and sy from the point where it was thrown. Okay, so if I can find out sy and sx and relate them, then I will get my y is equal to fx. Right, I basically want sy to be a function of sx. Once I have that, I basically have y is equal to fx, right? And then I could just find out the first order and second order derivative and get my rho. Okay, so let's find out sy, find out sx and try to relate them. Okay, first I am going to look for sx because it is a uniformly accelerated motion in that direction. Sx is going to be ut plus half at square at any given time t. Right, initial velocity is 0 since the body is starting from rest. Therefore sx is equal to 0 plus half. A is given as 2. Okay, in x direction your acceleration is constant and is equal to 2. So you have half into 2 t square. Okay, so what you get is sx is equal to t square. At any given time t, your sx can be found out by using this equation. Okay, now let's look at sy. For me to be able to find Sy, what I'm going to do is I'm going to write acceleration as dv by dt. Okay, so my acceleration at any given time in y direction is 12t square. Okay, so over here I would say that ay is equal to dvy by dt, which is equal to 12t square. Okay, we are doing the acceleration part in y direction. So I have this equation. I can write this as dvy is equal to 12t square dt, right? Let's now integrate it on both the sides. What I'm going to get is dvy is equal to 12t square dt. At t is equal to 0, which is the point when this guy was thrown, my velocity is 0. Okay, it is starting from rest. Therefore at t is equal to 0, my velocity in y direction is 0, and let's suppose at t is equal to t, my velocity is vy. Then what I get is vy is equal to 12 t cube by 3. Okay, this is my expression for velocity in y direction at any given time t. I also know that vy is equal to dsy by dt. Okay, so vy is equal to dsy by dt, right, which is equal to 12t square by 3. Okay, so I can write this as dsy is equal to 12 by 3 t cube dt, and if I integrate it both sides, dsy is equal to integral 12 by 3 t cube dt. At t is equal to 0, my displacement is 0. Okay, I am considering this as my reference point. So at t is equal to 0, it is at this point, so my displacement is 0, right? And at t is equal to t, let us say my displacement is sy. Okay, therefore what I would get is sy is equal to 12 by 3 t4 by 4. This is 12, this is 12, so basically I get is equal to t raised to the power 4. Okay, you have sx equal to t square, you have sy equal to t4. Okay, therefore from 1 and from 2, what do you get? You get that your y or sy is equal to sx square, right? Look, your sx is equal to t square. Okay, so t square, the whole square is t raised to power 4, which is what? Which is your sy. So your sy is equal to sx square. Now you have established the relationship between y and x coordinates of your projectile at any given time t. Now you can just use this and this to get at the rho. Okay, so let us see what is dsy by dsx. It is equal to 2sx, right? And what is d square sy by dsx square? It is equal to 2. So my rho, which is given by this formula, I'm just going to copy it and I'm going to paste it down. My rho is given by this formula. So my rho is what? My rho is equal to 1 plus dy by dx the whole square, which is 2sx. 1 plus 2sx, this whole raised to power 3 by 2 upon d square y by dx square. This is 2. Okay, so I have my rho equal to 1 plus 2s x 3 by 2 by 2. I need to find out my rho at t is equal to 5 seconds. Okay, so I have to find out what is Sx at t is equal to 5. My Sx at t is equal to 5 is equal to what? Let us see. My Sx is given by t square. So at t is equal to 5, my Sx is 5 square, which is equal to 25. Therefore, my rho at t is equal to 5 is equal to 1 plus 2 into 25 raised to power 3 by 2 upon 2. So this is your radius of curvature of the path followed by your projectile at time is equal to 5. Okay, just remember, whenever you have variable accelerations, you are going to use one of these three. Okay, you are not going to use this. This is only applicable when your acceleration is constant. Okay, let us take an example. Over here it is given to us that a projectile is fired with an initial velocity of 50 meters per second at an angle of 60 degrees with horizontal from point A. Okay, so it is something like this. Okay, it lands at B, which is this point. We are supposed to find the distance AB. Okay, so we are supposed to find this distance. Okay, so let us see how we are going to proceed in this question. In this question, we are going to have our axes like this. Okay, this is going to be my y-axis. This is going to be my x-axis. Okay, let us look at it in the diagram. It is given to us that the angle with horizontal is 60 degrees. This whole angle is 60 degrees. Okay, do you know this angle? This angle is equal to the angle of inclined plane, which is 30 degrees. Okay, so this is 30, this whole is 60, therefore this particular angle is going to be 60 degrees minus 30 degrees, right? So now my condition is like this. This is my x-axis, this is my y-axis. Okay, my projectile is having this trajectory. Okay, and this is the initial velocity, which is 50 meter per second. This angle is 60 minus 30. The angle of velocity, initial velocity with the inclined plane is 30 degrees. Okay, so now I have the initial conditions with me ready. My initial speed in x-axis is 50 cos 30. My initial speed in y-axis is 50 sin 30. Okay, what else do I know over here? I know that my acceleration is like this. Okay, my acceleration is vertically downwards. It is equal to g. Okay, what is this angle? This angle is the angle of my plane, right? This is 30 degrees. Okay, therefore, whoops, do we know what is the component of acceleration in this direction and in y direction? Let us find out. This is going to be perpendicular to this plane. Okay, so this whole angle is 90, right? So what is this angle? This angle is going to be 60 degrees and this line is perpendicular to this line. Therefore, this angle is going to be 30 degrees. Okay, so I'll just take this off. You have your G acting like this. Okay, so it is going to have a component like this and it is going to have a component like this. Okay, a component in this direction and a component in this direction. Okay, a component in this direction is going to be g cos 30, okay. A component in this direction, which is your negative x direction, is g sin 30, okay. So now we know that acceleration in x direction is minus g sin 30 and acceleration in y direction is minus g cos 30, okay. So I'm just going to write over here, along x-axis my acceleration is minus g sin 30, which is a constant, okay. Therefore I'm going to have a uniformly accelerated motion along x-axis. Similarly, along y-axis my acceleration is minus g cos 30, which is again a constant. Therefore I am going to have a uniformly accelerated motion along y-axis. Therefore, along both the directions x and y, these equations are valid, okay. S is equal to ut plus half at square, v is equal to u plus at, and v square is equal to u square plus 2as. I can apply both of these equations along x and y directions, okay. So if you look at this figure, you would realize that the net displacement in y direction is 0. It starts from 0, 0 and it ends at a point which is having a y displacement equal to 0, okay. Therefore I can say that along y-axis at point B, okay. What is your point B? Look, this is your point B, okay. Along y-axis at point B, your displacement in y direction is 0, okay. So along y-axis at point B, my displacement is 0, okay. Therefore what I would do is I am going to use S is equal to ut plus half at square in y direction and have S, which is my displacement, as 0, okay. So I am going to have 0 is equal to, what is your u in y direction? In y direction your u is positive 50 sin 30, okay. So you have 50 sin 30 into t plus half into, what is your a? Your a along y-axis is minus g cos 30, okay. Minus g cos 30 half a into t square, okay. So you have a quadratic equation, okay. In t you can find out your t from here. So I'm just going to get a t from this particular equation, okay. Once I have a t, I need to find the distance AB, okay. What is AB? AB is basically my displacement along x-axis, okay. So I'm just going to write over here, along x-axis displacement is, or displacement at point B is AB, okay. It is the length AB. Therefore AB is equal to, S is equal to ut plus half at square along x-axis, okay. If I am going to apply S is equal to ut plus half at square along x-axis, I am going to have this as the displacement, right. I know the initial velocity along x-axis, which is this. I know the acceleration along x-axis, which is this, okay. So AB is equal to ut, where u is 50 cos 30, into t, which you have got from here by solving this equation, minus half I've taken minus because my acceleration is negative along x-axis. It is minus g sine 30. Okay, so I'm just having the minus due to this. So I have minus half g sine 30 t square. T you know from the above quadratic equation. So if you are going to put in your value of t, you would get the AB, which was what the question asked for. Therefore your question is solved. Okay, so just understand that you can have x and y components of your velocity and acceleration along any directions. Okay, obviously x and y have to be mutually perpendicular. Okay.